We will be working in CodeApp to investigate relationships between engine displacement and city miles per gallon. So first, what exactly is engine displacement? Engine displacement is a determining factor in the horsepower and torque that an engine produces, as well as how much fuel that engine consumes. Generally speaking, the higher an engine's displacement, the more power it can create, while the lower the displacement, the less fuel it can consume. So let's go back to CodeApp. I'm going to create a graph. I need to scroll over to find engine displacement and drag that to my x-axis. Then go to city miles per gallon, drag that to my y-axis. I'm going to make this a little bit bigger so it's easier to see. So if I go over to my tools, there's a ruler that shows measurement. I want to click on least squares line. And this is just a fitted line that is often used to both describe the data and to predict values of one variable from the other. So down here it shows r squared equals 0.55. So just regular r would be about negative 0.74. So that means that this is a moderate negative correlation. Also down here it shows my y-intercept. So my y-intercept would be y equals negative 3.24 plus 31. So here we have engine displacement. So that is my predictor variable. Over here I have my city's miles per gallon. So that is my response variable. So next I'm going to add a third attribute, transmission type. So I'm going to just drag this here, drag it to the middle. Okay, and then let's make it a little bit bigger so it's easier to see. So with engine displacement, what he was saying earlier, if we look at this guy way up here, his engine displacement is 1.5 and his city mile per gallon is 53. So that's very good. So he has a low engine displacement and a high city miles per gallon. But this one down here, his engine displacement is 8.4 and his city mile per gallon is only 12. So that makes sense why we have a negative correlation, because the lower the engine displacement, the higher the city miles per gallon, so it just keeps going down and down and down. Anyway, so all these yellow dots show auto transmission, the purple shows manual transmission, and I was actually pretty surprised how many more purple were over here than over here. I just assumed that that it would be lower. Other than these two are definitely on the lower end. So if I go back over to my tools and I click least squares line, now it pulls up two of them. So there's one yellow line and there's one purple line to show the difference between auto and manual transmission. So here right now it's showing me my manual transmission line. So it has now changed. This one is y equals negative 2.87 plus 30.2. It also shows r squared is 0.652. So my r would be about 0.81. So that means that this, the graph for the manual transmission is more of a strong negative correlation. So that's good. That means that they're closer together. It's a stronger graph. If I go down here, it's a little harder to see, but this one is for my for my auto points. So this one would be y equals negative 3.33 plus 31.3. And the correlation is pretty close to what we had before. Next, I'm going to show the difference between, right now I've been doing engine displacement versus city miles per gallon, but now I'm going to show the opposite. So I want to do city mile per gallon versus engine displacement. So I'm just going to start over. So let's click on graph again. I'm going to scroll this over a little bit. Find city mile per gallon, drag that to my x-axis. Find engine displacement and drag that to my y-axis. We're going to see how much has changed. Let's make this bigger. Go to my tools, click on my ruler, find least squares line. Also, there are squares of residuals, so that just shows that's how to find my least squares line. Okay, so now it's showing we have the same R, so it means my correlation stays the same. I still have a moderate negative graph, everything, all of that stays the same. However, my y-intercept is different. Now I have y equals negative 0.17 plus 6.7. So now everything has changed. Now, now my predictor variable is cities mile per gallon, and my response variable is engine displacement. So this is pretty much just like the other graph, but almost flipped around. So if I look at this, this is about 10 miles per gallon, so they have a higher engine displacement. Whereas earlier we saw that other guy who was by himself, he's about 50, I think it was 53? Yes, 53, and his engine displacement is only 1.5. So now this just shows the higher the city's mile per gallon, the higher the engine displacement. While finding this information, we always have to keep in mind about the uncertainties. So if I click on count, it shows me that there are only 300 vehicles that we have been looking at. So it's a very small sample compared to all of the vehicles in the United States. If we added all the vehicles, our least squares line would change, our residual would change, a lot would change. So you always have to keep in mind that this isn't everything in the world or the United States. This is only just a very small sample, and it doesn't matter what you're working on in CODAP, you always have to keep in mind with that. I hope this helped you learn a little bit more of the relationship between city miles per gallon and engine displacement. I know I definitely learned that the higher engine displacement, the lower the city miles per gallon. So if you are trying to find a vehicle and save on gas, it looks like you should be looking for a vehicle with a lower engine displacement.